Okay, good. Thank you very much, and congratulations to stay here so late. We have been talking about machine learning, AI, DL all the day. If we take the comparison to what has been in the Hadoop environment and area, going to MI, ML, DL is not going to be easy neither. There are going to be challenges, and those challenges, we may find ways to simplify them. And this topic today is about how can we simplify the deployment of AI, ML, DL architecture in a distributed environment, and more precisely by using BlueData. So when we talk about large distributed environment running machine learning, deep learning, and artificial intelligence, the starting point, everyone agree on that, is we need data to train the models, accurate data, small, big, or both, and it will depend really on the problems we are going to try to solve. So the data scientists, they will need to access to different set of tools, obviously, and those tools, they will be from different sorts, different flavors. They need to run different sort of algorithms. There is no one single answer for everything. So tools, different tools, we need obviously to have architectures that are going to be massively scalable, powerful, and we are going to use CPUs, GPUs intensively. And we are going to face the problem of sharing expensive resources across different teams. So the problem is how we are going to be able to share those very first-class resources. Once we have built those models, once we have trained the models, once we have validated those models, how can we validate them on scale data, large-scale data, and how we can put that into production? So all of those questions are going to be challenges if you don't consider ahead the scalability of the solution. Developing on a laptop is quite convenient, but when you start to put that in a distributed environment, you are going to face problems like different sort of hosts, different performances, different libraries, different versions of binaries. It may be a problem to get a correct environment ready to run for you in few minutes. Once you deploy in a distributed environment, how you are going to share the data? Are you going to duplicate the data, as we are used to do by building silos, independent silos? And if you start to duplicate your data, basically you are going to introduce asynchronous data. And in the loop, you are going to start maybe to build models who are inaccurate. So that's the worst case scenario, basically. So how can you have access to data without to duplicate the data and letting you building more models and more accurate models quicker? And obviously, first-class resources like GPUs are expensive. So how can you share that between different teams, between different groups of users? So when we deploy like H2O applications in large-scale distributed environment on containers, it's a way to simplify the problems of deployment. And with BlueData, we address that. We simplify that. So basically, with BlueData, we aggregate the resources in the infrastructure in terms of CPU, storage, memory. We build up from those resources independent tenants based on quotas, CPU, storage, memory, GPUs. And we isolate all those tenants from each other. So groups of users can work independently on the same consolidated architecture, totally isolated from each other, and they can spin up and down the clusters they want. They can integrate different containers, different stacks all together, build different pipelines if you want, and at the same time, very easily, with a DevOps experience brought to the data scientist. So from a single web interface, they can deploy the apps they need, and they can connect those applications to the data. So the data don't need to be moved, staged into your clusters. You connect your cluster to your data through what we call the data connectivity. So the concept need to be is able to be deployed on premises, in the cloud, hybrid, or multi-cloud. So you don't need to worry about how is going to be the portability of your environment. It's going to run everywhere if required. So here it's an example of H2O pipeline. I'm not a data scientist, and I apologize if sometimes I make some wrong statements. But it's just an example of what we can do with BlueData. So basically, from a data scientist from the web interface can very easily deploy a driverless instance by using GPUs. So BlueData is going to spin up a container with GPUs on the correct host in the infrastructure, allocate a persistent storage to this container, and this container is going to be persistent. So the data scientist can stop the container, release the resource, and restart the containers or this container later on without losing any data. And very importantly, it doesn't need to copy the data inside the container. It's going to use the data type connectivity to connect the container to the data so that it can start to build models on accurate data and not copies of data that could be potentially be outdated. And once it's done, it can validate on other sets of data. And all of those data, they never need to be moved into the container. They are going to be consumed over the data type connectivity. And by doing so, it can very easily put his model into production and deploy that into other cluster of containers massively distributed on the infrastructure. So it can be H2O, it can be sparkling water. So those challenges, the traditional challenges, are solved with the BlueData architecture. We bring in pre-built images of H2O products, so driverless AI, H2O Flow, sparkling water. We bring in the appropriate NVIDIA kernel drivers and the CUDA framework when you need to use GPUs in your container. And the data scientist is going to be able to deploy the different clusters from his web interface or REST API calls, and then access to the different services from a web interface or CLI, web SSH or SSH. And then the infrastructure BlueData is going to map automatically the different ports of the services. So the data scientist doesn't need to worry about the implementation of the architecture. He can just consume the architecture, work on the data, and produce value, and stop wasting his time to try to develop the architecture itself. And we can have other ways to provide access to data. We can surface NFS mount points to be able to share assets between the different containers, different clusters, so that a data scientist can export his notebooks, his models, and propagate them into the next stage of the productionization of the model in H2O cluster or sparkling water clusters. So very easily, if we go through the journey of a typical data scientist, he will pick up some images from the App Store, prepackaged images from the App Store, and then those images are prepackaged by BlueData, or they can be built in by yourself. So you can bring in your own apps. So here it's just an illustration of what we can do, but any Linux applications that can be containerized or Java applications that can be containerized can fit into this model. We open the tools for the users to bring in their own apps. So once you have your apps in your App Store, the administrator of the BlueData platform is going to define which tenants are going to access to which applications to provide segregation between the different line of business, different groups of people. And the user is going to be connected to a tenant. And the tenants themselves, they will have some quotas in resources, in CPU, storage, memory, GPUs, and they have priorities. A production tenant may have obviously more priorities than a test and dev tenant. A Q&A tenant maybe have less priorities than the production tenant as well. And within the tenants, you will be able, as the administrator of the tenant, to define the flavors of your containers. So you may want some containers with 1 GPU, 2 GPUs, 3 GPUs, 4 GPUs, or more memory, more storage, more CPU. So that to match your requirements and for your workload. So once it's done, a data scientist will log in into its environment, and from the web interface, he can deploy some templates already defined by the tenant administrator. So he can pick up the flavor he wants to deploy, and deploy several clusters very easily from the web interface. Or he can deploy himself, pick up a flavor and a distribution from the list of pre-built images, define the number of nodes you want to create, and then validate. And in a few minutes, he has its full environment ready, running on containers, distributed across different physical machines. And again, those different environments are going to run in different tenants. So they are going to be totally isolated from the CPU, storage, memory, and network point of view. So different line of business, different customers, different groups of users can work all together at the same time on the same platform without to be seeing each other because they are in different tenants. So BlueData brings in the features of deploying automatically the containers and matching the container deployment on the correct host when you have the correct resources available. It's going to use persistent containers. You can start the containers, stop them, restart them later. You can resize your cluster, increase the number of nodes, reduce the number of nodes, and you can have a lot of different flavors of applications that you can use to build your pipeline. So it can be H2O applications, obviously, but you can use Cloudera, AutoWorks, and many other applications, streaming applications, Kafka, for example, Confluent Kafka, and so many others. And it's a true multi-tenant environment, basically, where every tenant is going to be running in an independent network, so that you can't see the workloads running aside of your tenant. And the last bit is we are going to apply enterprise-grade security on the containers. So if you have set up your environment with SSO, LDAP, AD, those configurations are going to be propagated inside the containers, so that when the data scientist is going to spin up his cluster, all his security environment is going to be propagated as well at the same time inside the containers it's going to create. And this way you can SSH on the containers and use your AD, LDAP credentials to get in. So it's a very a simplified illustration of what we could do with driverless AI once you deploy this cluster. So you log in on the interface, you import datasets from the data tab connectivity, you bring the data into driverless AI, which is running in a container on GPU with GPUs. You start to analyze the data, you start to build your model, you train your model, you validate your model on different datasets, and then you can export this model and put this model into production into an independent H2O or sparkling water cluster, which can be running inside BlueData as well. And you can validate very easily the scalability of your environment. So here it's an example of once you have created a sparkling water cluster, you can initialize this sparkling water cluster against a backend H2O Flow cluster. Very importantly, when we deploy the containers, BlueData is going to configure the different applications layer in the containers at the runtime. So you can have automatically, like the IP address, the host names, the different host part of the cluster automatically built for you. So like for the H2O cluster, you need the flat file, for example, if you want to initialize the H2O cluster. So all those runtime configurations are going to be updated by BlueData, and the data scientist doesn't need to worry about it. It's just going to be, as a service, a fully integrated H2O environment ready to use, and it is going to be the same exactly for driverless and sparkling water. So once we have said that, it's fantastic to be able to deploy very easily a fully integrated compute environment. But what about the data? And that's the concept of separating the data from the compute we are going to use with BlueData, where basically we are going to connect the different data sets to the compute clusters by using the data tab connectivity, which is a feature provided by BlueData, so that the data scientist doesn't need to copy in to stage in the data into the cluster. It just needs to point the job to the data through the data tab connectivity. And once you've done that, you can see further. You can integrate other clusters from the App Store. So there are several applications, and you can run different other sort of framework aside of your H2O environment. So you can have Kafka, Cloudera, Hadoop environment, and you can integrate notebooks and many other tools predefined, prepackaged in the App Store environment, and making the life of the data scientist much easier and more efficient, and obviously getting a shorter time to get value from the data you are going to analyze. So from the lessons we can learn from this topic is that we can obviously deploy a complex distributed machine learning deep learning environment on containers. The deployment of such solution can be complex when it's distributed, when it's about to access to the data. And using containers is a way to simplify the deployment of such binaries. And you need to configure them all together. You need to build an architecture, an application which is consistent at the cluster level. And BlueData really definitively help to do that easily, and bring as well the ability to share expensive resources across different lines of business like GPUs. And those resources are mapped and surfaced into the containers, where basically you can use the best GPUs into driverless AI when you run in containers. So BlueData has many customers worldwide into finance, healthcare, telco environment, and they are happy and really enjoying the ability to be able to spin up an environment very easily from a web interface and getting the containerized application up to speed and helping them to simplify the way to deploy their environment. So thank you. I think I got a few minutes to make a short demo, so I'm going to switch to the short demo. So when the platform is BlueData is running on premises, in cloud or in hybrid mode. This demo is running on systems hosted on the cloud, on virtual machines on the cloud. So when you log in as an administrator of the platform, you can define the different tenants, meaning the different groups we are going to be able to access to the systems. And to those tenants, you can create assign quotas in resources and priorities in terms of quality of service between the different tenants. So here it's a production environment. This production environment has no limitation in terms of core CPU, has some limitation, however, in terms of GPUs. So we are going to impose quotas on the number of GPUs available in this environment, production environment. We are going to give to this environment the maximum level of priority. Any user logging in this environment will be able to consume against the number of cores available in the infrastructure. And is going to be able to spin up from the App Store images available, which can be quite numerous. So we have some H2O images, but we have as well Spark, standalone Spark clusters. We have Hadoop, traditional Hadoop environment, or single standalone applications like MySQL. And we have as well streaming applications, Kafka streaming applications available, Confluent Kafka and obviously the Apache Kafka. So a user, when he logs into his environment, is going to be binded to the environment where he belongs to. So I have a demo user here, myself, logging to the environment, and automatically the system, depending on the settings, obviously, I have access to one tenant or the others, or all of them, depending on the environment. So I switched to the production tenant, and then I decide to create a cluster. So when I want to create a cluster, I have some templates predefined for me. So I can just pick up a template and say, OK, I'm going to deploy this template, name it H2O, and that's it. So this template here is going to basically to pick up one of the apps available in the App Store. So it's an H2O app. I'm going to define the number of containers in this H2O cluster. So one master and 3 slaves, basically here. I know the concept of master and slave in the H2O cluster doesn't exist, but here it's just for the sake of clarity. I'm going to decide to create a sparkling water cluster at the same time, and I would like as well to deploy a H2O Driverless AI single node on a container with 4 GPUs, 64 CPU, and 64 GB of RAM. So I'm going to run that, and that's it. So it's as simple as that to deploy a full cluster with H2O Driverless, H2O cluster, and sparkling water. And it's going to take, how long? 2 minutes, 3 minutes, and that's it. So as soon as it's created, as a data scientist, I can log on it, start to work on the data, and that's it. So while it's running, I can have a look at obviously the different flavors available for me in my tenant. So I can list the flavors, so we can configure the flavors to match the workloads we want to use. The tenants are connected to the remote data through what we call the data taps. So here it's just one data tab connectivity, which is going to host the data where I'm going to use. So I don't need to copy the data in my containers. I just need to use this path to connect and to give them to the application. So I just need to give the data tab and the full path of the data to my applications, and they are going to be able to see them. So the cluster will take more or less 2 minutes to build. That really depends on the workload on the system. And once it's done, my applications are ready to go, are ready to be used, and I can just log in and work on it straight away. So in the background, BlueData spin up the containers, allocate the persistent storage to each container on the different hosts. and provide the resources for the containers. For example, the driverless AI will require 4 GPU. So BlueData is going to spin up the container on a host with GPUs. So the system is ready now. And as a user now, I can straight away connect on H2O. So I land on my H2O Flow interface. And if I want, I can start to work on my data. So I say, OK, I would like to import files. Those files are going to be coming from my data tab connectivity. So I don't need to stage in the data inside the cluster, just importing the data from this command. So I just give the syntax data tab and then point to the data stored on my remote storage. Then I run the notebook, and H2O Flow is going to obviously import the data, and then I can parse the data, and as you know, now be able to work on those data and start to parse the data and then start to build models and so on, exactly as you are used to do with H2O Flow. And it's working exactly in the same way as the traditional. So this dataset, I'm just going to try to predict if my flight is going to be delayed. So that's all, it's done. And now I can build my model. I can consume the data on the remote repository without to have to ingest them on the cluster. My H2O cluster is running in containers distributed on physical machines. And depending on the property I require for this container to run on, I can have GPUs, like for this driverless AI environment. So here I connect on this driverless AI environment. I need to enter the license, which is quite normal. So just copy that, enter the license. Okay, so just save this license. Okay, so and then I can start to work on my datasets. So I can import exactly the same way datasets. So from a local file system, from a Hadoop file system, and from a data tab, BlueData data tab connectivity. So here, basically, I'm just going to give the path to this remote storage connected by the data tab connectivity. And I'm going to, for example, pick up this one, and then import that into driverless AI and work on the data so I can visualize the data. Current business, I would say, as usual, as you would do on a standalone classic driverless AI instance. And once I've visualized my data, I can start to predict and develop my models. So again, containerized environment running with GPUs on a distributed environment. I don't need to copy any data, and I can build my models straight away. So just going to select is delayed colon. I'm going to use GPUs, and I hit the launch experiment button, and that's it. So now driverless AI runs with my datasets imported from my remote repository using the GPU, and all of that is running in a container. It's persistent, so if I decide to stop this container because I need to restart it later on, I can do that. I'm not going to lose any data. And the resource behind, the CPU, the storage, memory, are going to, and the GPU are going to be released for other containers. So you can have this concept of sharing the GPUs by time multiplexing, basically. So once the GPU is released, it's available for other groups, and so on and so on. So that's the general overview of what we can do by using containers, deploying H2O application on containers and distributed environment, and all of that simplified by BlueData. Thank you.
Any questions, anybody?
Yes?
Thank you. I saw your slide number 2. I think it was slide number 2. Do you mind to go back to that slide, please? well, it was a number 2.
Number 3?
Yes, this one. Yes,
Okay.
this one. I was curious about what performances do you put on the y-axis on the
Which graph? The first, the second?
the top right one.
So it's, I mean, it's that's the precision of the models and the accuracy of the model. You need more data to get more accuracy on the models.
Okay.
And it makes sense, basically, to train a model on a small amount of data. It can be very quick, but because it's a small sample of data, obviously, you may lose a lot of information by oversampling your data. So it makes sense to get more data to train the models. The problem with that, it is going to take more time to crunch, and you need more resources to do that. So all combined, all together, you need CPU, you need GPU to be able to make models faster with bigger volumes of data. So if in that building process you have to copy, to stage in your data, and we're speaking of terabyte, maybe in the future it will be petabyte of data, it's going to take a lot of time. So the concept of connecting the compute to the storage and not providing and not copying the data into the compute makes sense to optimize this approach and avoid to start to work like on outdated data. So some customers we have, banks basically, they used to copy 360 times the data and start to work on them. So it's a nightmare and brings risks. It brings the problem of out of sync data. And the worst case scenario is to build a model on data which are outdated. You are going to need to retrain it a lot of time. So
that was actually, thank you very much. That was actually another question I had, but you already answered. Like you said that you can release the hardware when basically you're done.
Yes.
But the question is, if I had, I mean, you've imported with a CSV file, and for tabular data is a lot, right? But if we have 1 million of images or something like that, I mean, how does the containers handle the in and out of memory? And the second question is, do you also support the let's say, distributed environment, meaning multi-containers on multi-GPUs or multi-CPUs?
So multi-CPUs, multi-GPUs. So you can have a cluster, a HPC cluster, just because it's easy to represent. And BlueData is going to be installed on all of them. And you can create a virtual cluster of containers across all of those nodes. And they will be built into a single cluster, virtual cluster. And they will be able to speak to each other, even if they are running on different hosts. So you can bring some affinities when you deploy a container. You say, OK, I want to deploy this container on XYZ rack in my infrastructure for redundancy, for example. Or I want to have a container with GPUs, or this amount of CPU, or this amount of memory. And you can use different flavors in containers, so that is going to match your workload. So you can bring containers if you decide to process big images. You may want more memory for your Spark jobs. And you can define containers with more memory, basically, and use those containers, those flavors, for this particular workload. While at the same time, other guys in the team, they may want less memory on different flavors of containers, and they can use them independently. So all of those containers, you can configure the flavors as an administrator of the tenant, bring more CPU, more memory, more storage, or more everything for matching your workload.
And one last thing is, we learned this morning about some of the keynotes that it's not only about GPUs, but they are also very good option, as you said, to extend the memory. I don't remember who was mentioned this morning, but sometimes you can't fit all your data in the acceleration card. Now the question is, we saw a lot of like the CUDA libraries for optimizing the work on GPUs, but if there is a specific workload that doesn't require or can run without GPUs, is there any optimized environment within the container that run on each, let's say, either single or multi-CPU?
Yes, it's a good question. And again, it's the ability to be future-proof. Today, that's the context of the technology. It's that what we mentioned, GPUs and CPU. But the next step, we don't know what's going to happen. So you need to have a platform that lets you tune it, configure it the way it's representing the state of the technology, the state of the algorithm. Like TensorFlow, you have some versions running optimized only on CPU and not using GPUs. So you can deploy containers of TensorFlow only for GPUs on specific Intel CPUs, because you are going to execute specific instructions in the socket to optimize and to avoid to use GPUs. So you can have different containers with different stack of binaries inside the containers available in the App Store, and deploying them with affinity rules on specific nodes if you have some specific affinities like the CPU, SSDs, GPUs. And all of that is going to be transparent for the data scientists. You don't need to get headaches about how I need to maintain my stack. It's going to be done for you. So this App Store in itself is an ecosystem that is provided as it, and you can enrich it with your own apps, with your own environment requirements, security, binaries, libraries, and so on. So you are not locked in. It's the opposite. The tool is here for you to develop your own ecosystem and make it live and iterate and evaluate and change with it, basically.
Thank you very much.
You're welcome.
Any other questions? Awesome. Thank you so much, Yoann. Yeah. Thank you so much, everybody.